Now, next part, we're getting into expression and control structures. So inside Solidity, we have support for these keywords for control, for like for control, like logic control, thing like if, else, while, do, for, break, continue, return, try, catch. These are very similar semantics known from C or JavaScript. So whether you have been using on that front, it will be very similar. Try catch is used very often for like calling external contracts and using that for you to handle the issues with revert and issues with the external contract and so on. Yeah. So next part we're getting to is function call. So we can call function of one contract from another contract. So we have an example below with two contracts, caller and callee. We're gonna use remix to go over this example. So let's jump over to remix and copy this part. We're gonna make a new file called function calls. So you can copy this in. Alright, so you can Command S or Control S on Windows, and it's gonna compile, so everything works. Alright, so let's go over the two contracts, and then to understand how does it work. So first, let's go first contract, callee. This is contract that you will use another contract to call. So you have two state variables. One is x, the other one is value. And these two are unsigned integer, right? And if it's unsigned integer like this, it's gonna be 256, right? You also have a function called setX, and it takes in a number, unsigned integer, and it will return a number, another unsigned integer. And what does it do inside is it takes a number in and it sets the state variable x with that number, and then it return x. Right? You also have another function called setX and sendEther, and it takes in a number, but then it returns two numbers, right? Two unsigned integer. And what it does inside is it takes in a number, set the state variable x. Then what it does is it takes the value of the transactions. You see right here, message.value, which so when you interact with function, you can also include value of the transactions. So then, which is the native token that you want to send with the transactions, and that's gonna be what the message.value is, and then that's gonna be assigned to the state variable value, and then the function is gonna return both. So now let's compile these ones. I compile, and then we're gonna try deploying it and see what does see how does it look like. So you go deploy, you go right here, you see callee, you see 2, value, and x, right? These two initialize to 0 because you haven't set anything here. So that's the default values. Then you have two functions, right? So let's use these two functions, x first, right? So it's 0 right here. So now we do 1, transact, so it's gonna be 1. So we change it to 12, transact is gonna be 12, right? And so on, right? 100, yeah, I got 100 right here, right? Straightforward. Now we get to setX and sendEther. So essentially you can what you can do is you setX, let's say you do 10 here, and you can also sendEther, which is up here. Let's say you do ether, just do 1, make it simple, and then you can transact, right? This right here is 100, the last time we called. So now you transact, that is valid, it goes 10. Now the value is gonna be this number, right? It's not 1, remember, because 1 ether is 1 times 10 to the power 18. So this one is returning the value in way, right? So that's how Solidity works. That's how the environment, the VM works. Now let's go over to the contract caller, right? Let's go to caller. So caller is very similar, right? You have, but you have three functions. You have a function setX. What it does, it takes in a contract, right? So callee, which is this contract. So this is type callee. Essentially, you're saying it's taking in a contract with the type callee in this case. And what this one is actually an address, right? So it's taking in an address, and then a value, right? An unsigned integer, and then it also returns an unsigned integer. So what it does is it goes inside. You have a local variable x here, as this is not the this variable, but it's a local variable. And then what it does is it initializes the callee contract, and then you call the method setX of the callee contract, which is this one, and with the value that you pass here, and then you return X, right? And theoretically, this X is going to be the same as this one. And similarly for setX from address, so this is another way for you to do this thing, right? This one is you initialize that inside the input. This one, you take the address and you initialize below. So here the inputs are an address and also an unsigned integer. Then you go down, you have the syntax. You have a variable callee, so you initialize a variable named callee with the type callee, capital C, and that's a type, and that's equal to callee, the type, brackets, and also add in the address. So this is how you initialize a contract essentially. So it's not not creating a new contract. You initialize the instance of that contract for you to interact with. So then right below you do callee, setX, and pass in the numbers that you put it here. And the same thing here. setX and setEther very similar to the callee contract, except this time you initialize the callee contract inside of the input, and then you go down here, you calling the setX and setEther of the callee contract. You pass in the value, you pass in the X, and you return it. Right. So now let's deploy it and see what does it look like. Right. So let's just deploy callee color. Right. Deploy. Now this is right below, right here. Now, right here, you having like 10 and this one, right? So you have these two values. Now you go down here. Let's do setX, right? So you put the address of this one in, which is this called callee. See, actually, let me show you this. See, the input here is called address. So what you're doing is you're adding in the address of this callee contract. And then you're going to do, so this is 10, right? Let's do 5. Right? And then you transact. Works. Next thing you check this one, it's 5, right? So now, similarly, for actually, let's do the address. All right, this one, so the address. This also will work the same way. So now we're going to bring from 5 to 5 here and bring it to 10, right? So bring it to 10. And that's going to be 10. And now you also send ether, right? Again, you put in the contract, and then your X is gonna be, you have 10 here, that's 1, and then the value you're gonna put in is 1 ether, right? So right now the value here is 1 ether in way. So now you transact here, set X and set ether, transact this one, and the value would be different. Oh, which is still 1, I guess. Yeah, maybe you should do 2. Yeah, let's do again. Let's do 2. I guess it's just to set the value. It doesn't add it in. But you have balanced 2 ether here. That means the contract only received 2 ETH. But let's do a little bit different, just so we can see the difference, right? And it's this one's 1. This one is 1 ETH in way. Then let's do this one's 2, and that's gonna be 2 here. Right there, as you see it changes. Yeah, so that's how you call a function of one contract from another contract. Lastly, in Solidity, you can create a new contract with the keyword new. So using the keyword new, you can create a new contract, and we will go over an example of this in advanced storage.sol example just right next to this part.